Hey, hello everyone. Hi. Hi Pradeep. Hi Amit.
Hey
Hey,
Rajendra,
Rajendra.
Hey Durai.
hey
Hi.
Pradeep, hey Amit, hey all.
Hey,
Hello,
I hope
good
I'm audible.
afternoon. I can. And you guys all hear me okay?
Yes, Pradeep, we can hear
I
you.
can.
Yes.
Yes, yes.
Yeah, sometime the
Yeah, we have
background
some time.
comes. I'm just
Yeah,
putting my headset so that you guys don't hear some background.
sure, Pradeep.
हाँ बोल सभी मीटिंग बताओ सुबह से मीटिंग में ही बैठे बहुत सारी मीटिंग तू मुंह में ठूसा बैठा रहा कर जब देखो तो
We'll just wait for a minute more and then start. Okay, I think we are good to start now. Hi, good afternoon, everyone. My name is Rajendra. I work for NIT StackRoute. I lead the strategic accounts here at NIT StackRoute. I welcome you all to this special webinar on the next frontier of SRE, which is an architecting AI-driven autonomous operations. Thank you very much for taking out time to join this session today. Has been disrupting our work, but we all should also know that SRE has been equally impacting our life and work. So before we begin the webinar, and I let the eminent speakers take over, let me take a couple of minutes to take you through what we do at StackRoute and give you a brief about StackRoute and our capabilities. Could the next slide, if you could move, please. Yeah. So StackRoute is an NIT venture. We started as a product engineering company, a startup in 2015. And as part of NIT, we provide custom learning solutions which are designed for business aligned talent capabilities. So we try and understand the actual business problems and design tailored solutions or interventions with measurable business outcomes. And we cater to tech professionals across the entire life cycle, beginning with freshers who are entering into the system, existing employees who are there, and then also senior professionals who are there in the organization. So at an entry level, if you see at the bottom of the pyramid, we offer programs like boot camp for campus hires across all technology tracks. At a mid-level, we offer deep skilling programs for employees, which could be in any areas, including SRE being one of them, cloud, digital, AI, and others. At a slightly senior level, we call them as transformative programs. So there we offer various kind of programs, including product management, architecture, even SRE program for architects. We offer entire range of delivery excellence programs and all of that. Now, the focus at the boot camp and deep skilling level is more on skilling, and making you more, making one more strong on the technology part of it. And at transformation level, the focus is more on building transformative competencies, which will help individual transform or move to a technology leadership ladder, in the technology leadership ladder. So we partner with large as well as small scale organizations. We work with GCCs, GSIs. We work with analytics organizations. We work with consulting companies and also and product engineering companies and teams. So we work with organizations across all levels, and we have been delivering quality programs across all these organizations. And when we talk about quality, how do you justify it? And a testimony of those is the Brandon Hall Awards that we have won year after year. So if we see, year after year in the last 4 years, if I see, we have won more than 50 Brandon Hall Awards across various programs with our customers. And in last year itself, we won 15 Brandon Hall Awards. Now, what StackRoute, how StackRoute is different, and what is it that we are doing for the larger community, and that's where the differentiator for is the kind of thought leadership initiatives that we have been creating and working with the larger community, to bring together larger communities. And one such community like the architect, the architect community, what we have done is we have built an initiative called the Digital Architect Conclave. Now, this is a thought leadership initiative we created in 2023, and we have been doing this conclave every year. We normally do it in the month of July, and we have seen last 4 years, more than 40 organizations participating in each one of them, with more than 120 plus delegates attending each one of them. And these are all tech architects, CTOs, vice presidents, solutions and enterprise architect, people of that level who have been attending, and they have been all praises for this this community that we have created and we have built. So this is something that is our way to give back to the community, the architecting community. Now, one of the follow through of the digital architect conclave is what next? Why do we do digital architect conclave once to keep to give more to the community? We have been running this series of webinars. We call them as Stay Ahead with StackRoute webinar series, and today's webinar is one such of them. Moving to the next, today's, before I come to the webinar, I also wanted to tell you that we have built a very strong capability around site SRE. And this is drawing from our experience of working very closely with organizations of various scales. It is clear that organizations today are striving to establish a strong foundation in SRE. And to support this journey, we have developed a very comprehensive suite of solutions to enable businesses to shift from a reactive firefighting approach to a proactive and systematic model of reliability management. So we have created, what we have done is we do it at 5 different levels. If you see here, this slide clearly represents that. The first level is where everybody speaks the language of reliability, and then we move next to building or engineering the reliability. And then the next is, once you have started to speak and engineer, how do you scale it? And then once you've started to scale it, how do you ensure that it is efficient and cost effective? And then you need to also streamline the efficiency and bring intelligence into it, right? And then finally, you elevate it and you create approaches where one is architecting for reliability. So this 5 stages is what the idea and the thought process with which we have created our program covering the entire life cycle of SRE. Now, catering to each of these phases, we have come up with programs and have successfully delivered many of these programs across multiple Fortune 500 companies. Companies of the likes of CTS and Dell, we have delivered programs for them. And if you see at an engineer level, we have done deep skilling program. The focus of these programs is to help engineers move to a proactive mode and also ensure that there is reduced firefighting through automation. So the focus of the program is that. And as you move to an architect level, where you have SRE for architects, the objective then is to develop a core foundation which is needed to architect systems at scale, which do not break. And in today's world, how do they leverage AI across the entire life cycle? So that is the focus at an SRE for architect level. And then finally, architect-led SRE for business reliability. At this level, the focus is beyond architecting reliable systems. And we focus on trying to be always on service while reducing cost to serve and delivering excellence, exceptional customer experience. So this way we have tried and focused our programs on SRE across 3 different layers. Now, without taking much of your time, I will now quickly introduce the guests or the speakers, eminent speakers who are there. We have Mr. Pradeep Kumar Mishra, who is a senior director of Dell, who is a senior director of data engineering at Dell Technologies. We have been working very extensively with, Pradeep and his team. And thank you, Pradeep, for taking out time and joining in this session today. We also have Mr. Amit Gandhi, who is the co-founder and the chief technology officer at Parkar Digital. Then we have Durai, our practice head for cloud and digital at StackRoute. While Durai will give a detailed introduction of both Pradeep and Amit as we move forward, I will now pass on the baton to Durai to take it over from here and start the journey of this SRE today. Over to you, Durai.
Thanks, Rajendra. So once again, welcome all. So before I hand it over to the eminent speakers from Dell and Parkar Digital, let me quickly take you guys, or basically, setting the context why this, the session, or why this conversation matters. You can move to the next slide. Yes. So the next frontier of SRE, moving from reactive ops to intelligent reliability. See, modern production systems that are getting built today are no cloud native. It's all distributed and it's continuously evolving. We are dealing with microservices, APIs, event-driven architectures, and frequent releases or speed to market, right? But if you see the SRE right, on the SRE front, most SRE teams are still operating in a reactive model, right? So alerts trigger after impact. Engineers manually inspected dashboards and logs. A lot of time is spent on firefighting, right? So the problem is not really about the tools, right? The lack of tools or data. The real problem is human-only operations, which doesn't scale with this level of complexity. That's why we see the next frontier of SRE emerge from a shift from reactive operations to intelligent reliability, where AI, in fact, helps SRE teams to detect issues earlier. So more of a predictive and autonomous system, we can say. AI helps SRE teams detect the issues earlier, understand them faster, and eventually prevent failures. Right? So this opens up a question leaders often ask. So why is this shift happening now? Why not later? Right? So there are I can say there are three things which converge at the same time. The system complex, the system complexity has crossed a tipping point, we can say. Human reasoning alone can no longer keep up with the speed and scale of modern platforms, the way at which, the pace at which it evolves, right? Then the cost of downtime has increased dramatically, not only in terms of revenues, but also in terms of customer trust and regulatory impacts. And AI disrupted, it's disrupting everywhere. So AI has crossed from experimentation to reliability use cases. So these three things are converging at the same time, which has necessitated the shift that is happening now. Okay. And so the shift is required, the decision making is required, but what exactly is actually slowing the progress, right? So who owns the reliability decisions? Who is accountable when AI recommends an action? How much autonomy are we comfortable giving the systems, right? So these are not tooling questions. We can say these are leadership questions. And so AI doesn't replace SRE engineers. In fact, it changes what is possible for them, right? So the new frontier for SRE is already set. And the paces or the transition, we can put it into three different paces. We can say from moving from visibility to intelligence to autonomy. The first stage, visibility, most of the organizations are currently here today. So organizations have metrics, logs, traces, dashboards, alerts. A lot of tools are getting used. Much awareness, so it gives a lot of awareness, but not really the decisions, right? So we can see problems often after users are really impacted, right? So it's more of a reactive in nature. So the visibility is there, the current stage, we can say, but it has to move towards intelligence, right? That's where AI ML start to assist SRE teams, right? So how to detect anomalies instead of just relying on some static thresholds, right? So alert gets triggered when a threshold is exceeded, right? So alert gets, instead of that, actually detecting anomalies, instead of relying on static thresholds, correlating signals across services, reducing alert noise, right? So that the teams can respond faster. So that's the second stage, we can say. So visibility to intelligence to autonomy, right? So observability, of course, replaces basic monitoring, more on the intelligence side. But the third and critical stage, we can say, the stage where we are heading to, or the SRE is heading to, right? That's autonomy, right? So that's where SRE is heading to. Systems begins to predict failures even before the impact happens, right? Coming out with or giving some recommendations, safely executing the remediations, right? So having said this, autonomous, getting it, knowing the or predicting the failures before impact, even setting all this, we have to really reset the expectations through automation. So autonomy does not mean blind automation. It does not remove humans. So that is another thing actually in visibility. So human involvement is required at all stages, right? Or be it in visibility or observability or even in autonomy also. It's not removing humans from accountability. Okay. It does not skipping governance, though building autonomous system, which will go with the predictive model. We are not really looking in this, not really looking at skipping the governance or the controls. So autonomous SRE, we can say human defined intent policies with the risk boundaries, right? So and the AI should operate within that boundary. It's more like autopilot taking over, right? Or highly trained co-pilot knows when to act and when to ask. Okay. And so as AI enables earlier detection and faster response, it has become more business reliability function than an operational activity, right? And so through this session, through this particular webinar, one key takeaway I want to leave you all is that the autonomy without visibility is dangerous, right? Without some level of governance, right, which is dangerous. Okay, so autonomy without visibility is dangerous, and the intelligence without clean signals, right? So what do we really expect out of it? So without intelligence without clean signals is also ineffective. Okay. So, yeah, so the third, so leadership priorities for autonomous reliability. So what does this mean for leaders, right? So AI-driven SR is not just a tooling upgrade, right? So tools are already there. Is it just moving from tools to, bit of, say, AI is, impacting everything, right? It's disrupting everything. Is it just the tooling plus the AI? It's not really, right? So it's not just a tooling upgrade. It's more of an operating model change, we can say, right? So one common pattern in SRE, see if you notice issues, so the organization jumps directly into the tools, right? So they buy AIOps platforms, some detection engines or GenAI co-pilots, right? So, but that's alone will not change, right? It requires a complete change in operating model, right? So AI generated insights which anybody or which the organization could trust. So that's what is required. Alerts are created. It should be smarter, right? Alerts should not be ignored. Automation exists, but it should be allowed to act. That's where actually the leadership priority matters. So there are three, different, things we can say: people, platform, and practices. So SRE teams can no longer operate in isolation. Reliability today requires a lot of collaboration across teams, SRE, platform, cloud, data teams. Skills are really shifting towards system thinking and data literacy. And on the other side, the platforms, so high fidelity observability is foundational. So poor telemetry will lead to poor AI outcomes. We need clean, reliable signals, which are prerequisite for anybody to follow. Right. So platform plays a critical role, we can say. People, you have platform. Practice is very important, right? So reliability should be shift to left, right? So left shift, right? So we always talk about it. So reliability must be shifted left into development pipelines, right? Your SLO should be your the guide, right, to take decisions, right? Accordingly, automation should also be introduced. So with this, let move to the next slide. Okay. So with this framing in place, let me hand over it over to Pradeep. So Pradeep Mishra, he brings in deep hands-on experience from a large-scale enterprise environment, you all know. So he's a senior director with Dell. We also have Amit Gandhi, who is from Parkar Digital, the co-founder and CTO. So I will see. I have kept this whatever these slides and the content and the discussion to at a leadership and at a maturity level, because we have eminent speakers who can talk more about how these ideas holds up in large scale production environments. So which they which is their core background, we can say. Hearing from the industry leaders, that will be a very ideal one. So that's where actually Pradeep's experience is also invaluable here. He will take us forward with the practitioner lens grounded in real systems, real data, we can say, and of course constraints. Okay. So thanks for your time, guys. I will hand it over to Pradeep to continue with his discussion. Thank you.
Thank you very much, Durai.
Yeah. So sorry,
you can
Pradeep,
hear
let
me?
me quickly run through your profile also. Sorry about that.
No worries, go
So
ahead. I like my
yeah,
picture, by the way.
yeah, good, yeah. So Pradeep, we work. StackRoute works very closely with the Dell, and in fact, we work very closely with Pradeep Mishra, and he is having rich experience in the industry, and more than 20 plus years of experience, and more on the data SRE and on the AI front. Won multiple awards actually as technology leader, and so of course he lets the managed services in Dell, and so thanks, Pradeep. Welcome. Over to you. Thank you.
Yes, thank you very much, Durai. First of all, thank you so much, NIIT StackRoute team, for having me over here. I am already enjoying this space over here, and hopefully we'll have some great discussion with Amit, and it is great pleasure to be alongside with Amit and honor to have this interesting topic of discussions. Good afternoon, everyone. A little bit more from my side, what I'm doing now within the Dell. Um, Currently, this is my 6th assignment within the Dell, and there is one liner given to me, keep the data ready for AI. That's where my job starts bringing in this data modernization exercise, what I'm currently driving. Interestingly, we were talking SRE, and in my 6 different assignments within the Dell, I'm very fortunate to work with a direct SRE team with best of SRE leaders within the Dell, which I learned a lot, or I'm in direct in charge where SRE is part of your delivery. SRE is not a separate functions, and we will talk a little bit more about it. And currently, I'm in a process where we are trying to build a data prod ops, which is a kind of SRE aspects. And when we were talking about application SRE, and then we are talking about now the AI and data, and how does this SRE actually changing? So I'm hearing echo. I think it is good. So I will touch upon, but interestingly, if we can move to my next slide, please, Woody. We all are in a very interesting stage in the industry, I would say. Excellent competitions between human and machine, I call it, and very healthy competitions. And in the last 75 years, I think this competition is getting interested. The time span of machines becoming more intelligent than human is getting shortened. And that is really puts the question, and very rightfully, Durai was trying to point out, hey, where I should keep human in the loop, how, what is dangerous and what is not dangerous. We really need to find out that piece. Coming back to this human and machine competition, if you will see the amount of data growth happening, it is very, very exponential at this point of time. And why this is happening? Because we are getting very great amount of computing power coming in, and very easily available storage is available. So amount of data per day we are turning, that is very interesting, and the human and machine competition is becoming interesting. But coming back to our reliability challenges, what we were seeing, be in application and particularly in an enterprise structure. I would see this is actually in a transformation stage, and something in the similar line what Durai was telling. When we were starting 10, 15 years back, our reliability was pretty manual, very static. All the enterprise will have KPIs, the incident management systems, and very reactive in nature. And in enterprises like us, we were having a very nice major incident management, where we have prioritization of incidents like P1, P2, P3, P4. We have SLAs and SLIs being defined over there. And we have created a very nice structure over this. What we call that at this point of time, we were very reactive. And we actually putting a brute force to making our operations runs. Very nice, and we become very matured over there. We started introducing various monitoring tools, the metrics, logs, and traces. What we are collecting from various applications was very disconnected, and the challenges of incidents over there was done. But as we move from this reactive stage, I'm very much within the transition stage. And if you can hit one more enter button, please, Woody, if you will see. And here, maybe most of us are in this stage. We are trying to do proactive, but I was very fortunate enough to work with our e-commerce team 5 years back. And that's where the time I was learning what is that proactive means, and very fast, then how a system reaching a point, I'm not allowing it to break, but I know it is going to break. Very simple example, if my CPU are hitting 85%, can I get an indication and start working on it? Instead, I'm trying to find that it is breaking. And those thought processes were actually this proactive thought process 4 to 5 years back, when we were deploying in our front offices, when I was working very closely with our reliability leaders. And these aspects were very, very impactful doing. I don't know how many of us really using ML models to predict detections, but some of these minor rules were actually helping us, addressing this and reducing the noise, attaining the maximum MTTR, reducing your toils over there. And those were the things we were looking over there. If we will see that aspect, that was the time when we started talking that how we can shift left. So reliability is not a siloed functions, rather how we can shift left towards more from the design and development side. I start thinking when I'm building my CI/CD pipelines over there, and how I can enable those practices and put some reliability functions in the pipeline, so that I'm thinking reliability ahead in the game. So that's where the proactive stage, and we might be transitioning to this stage at this point of time, and some of forward-looking organizations might be implementing. But as Durai and Rajendra was pointing, I think this is where we all need to brainstorm the next stage. If you could please bring it on the next stage, and which we all kind of trying to find out what is autonomous stage. And that's the place where we are trying to bring in machines into the play. And we are trying to leverage machine intelligence into this play. How do I really close the loop? Now, what has happened? A data pipeline broke. Why it broke? So when we created an alert, an alert created, then the next thing is, am I creating an incident depending on the high priority, depending on the data, nature of the data? Then what? We are leaving it there, and somebody to come and look into that. 80% of your data pipeline fails because of resource challenges, because that could be one of the thing could be there. Rerunning the job might help because the resource was not helping. Very simple. 80% of my data pipeline can be recovered by taking a simple action of rerun. Very simple. I learned it from my childhood. Restart your machine if it doesn't work, right? That's a very simple solutions we are talking over there. But if you will look that how do I take from this piece and bring in some intelligence, you can call it agents or whatever, but and we call it an minimal human interventions, because that's where we all need to start designing the closed loop remediations. That's what we are looking. And then, as I took example, how do I take some actions to self-heal? Those are the processes. Define some rules. And certainly some rule definitions we need to heavily guard with the privacy and security, and to not need to give a lot of empowerment to some machines where this can be as dangerous as Durai was pointing over there. The third thing is, again, not talking about the co-pilots. There are several GPTs are available, and Copilot is as an example. How we can allow these agents that why this data pipeline failed in the very first tense. Is this because of a resource problem? It is a code problem, or it is not scaling depending on the data it is carrying, correct? It's very simple RCA. And it can create its learning through a runbook generations. And we're actually in a very initial stage of doing these things, and very interesting aspects what we are looking over here. And then can we create a context-based LLM or SLMs which will start learning these behaviors from their perspective, and change the mindset of reliability, which we call is AI-native operating model, but we can call it everything is. But if you'll see from reactive to proactive to autonomous stage, or the way Durai was pointing out, the intelligence reliability. And that's where this transition is happening from the roadmap perspective. But what we are getting out of it, I mean, if you'll just stay in the slide for a few more minutes, say that what's the outcome we are looking across the stages, and why we are doing, because what I am a firm believer at this point of time with this human and machine competitions, we as human, we really need to take control of this why part, because the how part is pretty much machine started doing it. Look, from these three different stages, I think our MTTR, where earlier it was taking hours or days, it should transitions to seconds. Pipeline failed, it's up running. That should be the vision or view we should be looking. Again, it varies depending on the complexities, what we are talking over here. And then change failure rates. Anything we are changing and how we are managing the failure rate from the different stages, somewhere to 20 to 25% when we started from our manual way of doing the things and to the autonomous way of thing is from 20-25%. If it is can bring down to less than 5%, and I think that's the outcome we are looking for it. SLO compliance, a very inconsistent to predictable, because we can predict if my 85% processor or CPU is getting consumed, then it will fail. Or a simple ML model can predict your incidents over there, then how we can really get an 100% compliance over there. And then the one of the top conversations what we are doing over here with the cost of these operations, what is the cost of an issue happening during the productions, and how much cost we should be really spending on a engineering dev time, and who will be taking this responsibility. And I think if we can reduce the human engineering time from X percentage to Y percentage, I don't know what is that Y percentage, but that is where the outcome I'm looking. So basically, with this autonomous or intelligence stage, I can actually come down to these labels, and that would be very helpful for me. I'm hearing a bit of echo with you. I'm not sure if I can move to the next slide, please. Yeah. So I think just trying to set up a context. You guys are hearing echo or good? Okay. So just, and this is my last slide. I will not drain it, and I will hand it over to Amit next. But why the AI native is the need of the hour? I think that's where and you guys all feel to agree, disagree, and this is a learning sessions we will think is. As Rajendra started that, the complex modern systems, and unlike Dell, and everybody must be doing. We are writing so many microservices. We are coming up with the distributed systems. We are building our data platform on-prem. There are data platforms where hybrid or public clouds we are doing. So we can see there is increase of operational complexity and the deployment velocity over there, because this is number one things what we are looking. If there is any interruptions or anything happens during this time, there is a cost of downtime, and that's becoming very high at this point of time. And this is our experience also to fix something in the production. And it's a very known phenomena because the biggest problem is if you are not reliable, if your data is not reliable, if your data is not trustworthy, you will lose your consumer in known time. And that quantification of cost is very, very difficult at this point of time. And the third thing what I am visualizing is, and this is all of us witness, every time I open my email, thousands of alerts, what we are doing with these alerts, the metrics, logs, stresses, failures, and all those things. Now, how do we take all those things and start trying the operational insights out of it? And I think that is where the need of the hour. And then the last one, but there will be many one, but this is my point of view perspective and looking what this AI native SRE reduce. As I told this MTTR, I'm trying to see that if we can bring it to the seconds actually from hours to days, and how we can bring these automations. And there's various implementation options. This is not very limited, but there are a few things which we are practicing or trying to do it over here. This is a very interesting and challenging journey that how you are transitioning this perspective. And for these operations on the data sides, I'm currently in a process to stabilize and put up these things. And there's a lot of does these things. There in industry, we have observability tools, particularly for data, moving from applications perspective, which could come into the play over here and help into our reliability uptime over here, building quality and trust. But if you will see in the current need, what we are looking that how we can feed clean data with high trust and reliability at a lightning speed, because that's what consumers are looking. And all these autonomous or intelligence thing cannot stay away. We have to bring it to the forefront. We will come back with more questions, but I would like to hear Amit's perspective, who is really driving a lot of great things from his organization's perspective, and we will get back. Thank you very much for hearing my point of view over here. Over to you, Amit, please.
Thanks, Pradeep.
Thank you, Pradeep.
Yeah, so before handing it over to Amit, would like to thank you very much. Thanks for this wonderful insights and information, taking us through the SRE transformation stages and why AI native SRE is required, what are the implementation options. Thanks, Pradeep. So guys, with this, we'll move to the next one, production grade AIOps from alert queues to self-healing systems by Amit. So let me quickly introduce Amit. So Amit is the co-founder and CTO of Parkar Digital. He's having 20 plus years of experience building and scaling global engineering organizations. Having experience in different domains, and he founded and led centers of excellence in AI, data, and platform engineering. With this, I will hand it over to Amit.
Thank you,
He can help us to understand how a large organization like him operationalize and scale production grade AIOps. Thanks, Amit. Over to you.
Thank you so much, Durai and Pradeep. Extremely excited to be here. Very briefly about me, Durai has already mentioned, but over the last 2 decades, I have helped scale global engineering organizations and led cloud data and platform modernization programs across multiple domains for Fortune 500 customers. Most importantly, I've spent a lot of time where these ideas either work or break, in real production environments with real on-call teams. So what I will discuss today is grounded in what actually holds up at scale. And my focus today is extremely simple. You might have heard two words again and again from Durai and Pradeep, correlation and context. I will discuss about how are these interrelated and what does production grade AI ops actually look like and why it only works when you correlate that with SRE. If you could move on to the next slide, please. Now let's begin with the reality most teams are living in today. Traditional monitoring simply collapses under cloud native and microservices architectures. The complexity of applications, especially with the advent of AI, is only increasing, and some of these typical tools are not able to keep up with that. What we have done is we have responded to that by adding more tools, more more alerts, and many more dashboards. But here is the uncomfortable truth. More alerts did not make us more reliable. Teams now receive millions of notifications a day, yet they still miss the incidents that actually matter. That's why I say fatigue is not a tooling problem, it's a systems design failure. We have created environments where engineers are drowning in signals, but they're still waiting for insight. And in that vacuum, we fall back on heroics. You always have that one engineer in your team who knows the complete system inside out and is helping with these critical alerts. But fire firefighting replaces systematic reliability engineering. We talk about reliability constantly, but in many organizations, it only exists in PowerPoint decks than in system behavior. This is the problem that AI ops is supposed to solve, but only if we approach it correctly. If you could move on to the next slide, please. So if the problem is not a lack of tools, what actually changes the outcome? It only happens when we stop looking at SRE and AIOps as separate initiatives. In production, they have to operate as one system. SRE defines what good looks like. SLIs, SLOs, and error budgets create the guardrails for reliability. AIOps, on the other hand, is how we operate within those guardrails at scale. It's how we detect patterns, correlate signals, and automate responses without burning out teams. This is also where observability changes its role. It stops being a collection of dashboards and becomes the control plane for reliability decisions. And when this works out well, something important happens. Automation replaces your heroism, your engineer who knows everything. We now stop relying on individual engineers to save the day and start designing systems that protect reliability by default. This operating model is the lens through which the rest of this presentation should be viewed. If you could move on to the next slide, please. Once we agree on the operating model, the next question is about execution. And this is where AIOps efforts quietly break down. AI cannot fix poor observability. If your metrics, logs, traces, and events live in silos or do not have the proper context, no amount of intelligence downstream will help. High fidelity observability isn't about collecting many more data points. It's about collecting the right data points with the right context. Context matters more than volume. Business metadata, service ownership, dependencies, these are what allow systems to reason, not just report. This is why observability is fundamentally a data engineering problem, as Pradeep rightly mentioned, before it's an operations problem. Clean pipelines, controlled cardinality, and enriched telemetry are prerequisites, not optimizations. Let me give you a quick example from a US-based high-tech SaaS company that we work with. On my very first discussion with their head of SRE, he said something that has stuck with me. He said, "We have invested a lot in AIOps, but my team is still afraid to be on call." They had anomaly detection, correlation, even some automated responses, but every real incident followed the same pattern. A spike in their checkout latency would trigger multiple alerts across API gateway, the user profile service, pricing engine, Kubernetes nodes, and the underlying cloud database. All the alerts were in fact technically correct, but none of them were helpful. The AI ops system could not tell that the real issue started in a recent config change to the pricing service, as an example. It did not understand that pricing was upstream of checkout, or that checkout latency directly translated to revenue impact. So engineers ignored the recommendations and went back to their manual triage. The turning point came when we stopped tuning models and fixed the foundation. The engineers unified telemetry, explicitly modeled service ownership, dependency paths, and business criticality flows like checkout and billing. Once the system understood that context, alert volume came down significantly, not because alerts were suppressed, but because the alerts finally understood what mattered. That's when AIOps stopped being impressive in demos and started being trusted during real incidents. Next slide, please. Now, once the observability foundation is in place, the first place that AIOps delivers outsized value is signal to noise optimization. This is where reliability stops being a concept and starts being felt by teams. Most environments do not suffer from lack of alerts, as I mentioned earlier. They suffer from lack of prioritization. So the objective here isn't suppression for the sake of quiet, it's about relevance. Events are deduplicated and grouped based upon service topology, timing, and impact. Alerts move from infrastructure level symptoms to service level signals aligned with user experience. And when you anchor alerting to SLOs, something important happens. On-call engineers stop reacting to noise and start responding to what actually threatens reliability. That's how you get dramatic alert reduction and real MTTR improvement. More importantly, this is how operations becomes sustainable again. Good AIOps doesn't just protect your uptime, it protects human attention. Let's move on to the next slide, please. Now, once we have reduced the noise, the next important thing becomes all the more difficult. Understanding why something is failing in a highly distributed environment. And always remember this, incidents do not happen in isolation. They propagate across services, dependencies, and regions. Yet, most of the SRE or the operations teams that I have seen still investigate incidents one alert at a time. That is where, or this is where, correlation fundamentally changes the game. Instead of dozens of disconnected alerts, related events are stitched together into a single incident narrative. Topology and timing reveal which signals are causes and which are downstream incidents. Dependency maps make your blast radius visible in seconds and not minutes or hours. And with enough historical context, ML-assisted diagnosis can surface the most probable root causes early in the incident. Let me give you a different kind of incident, one most large teams understand. During a regional traffic spike, a customer-facing application began to slow down. Alerts fired across the API gateway, authentication service, downstream partner integrations, and the database. Nothing was failing hard, but latency is creeping up everywhere. Something is about to happen. The incident bridge fills up fast. The API team thinks it's about auth. The auth team thinks it's a database. The database team sees nothing is obviously wrong. Everyone is reacting to what they can see locally, but no one could see how the failure is propagating end to end. Now, with correlation in place, the picture is completely different. Events across services are stitched into a single timeline. Dependency mapping shows that the impacted paths now converge on a single external integration. Tracing reveals increased latency from that dependency during peak load, not failures, but just slower responses. That slowdown quietly backs up alerts across the system, cascading latency upstream. Instead of debating for hours, the system surfaces this pattern in minutes. Traffic is now throttled, a fallback path is activated, and the system stabilizes. MTTR comes down significantly, not because the fix was complicated, but because the system helped teams look at the entire picture. And once you can reason about incidents, then you can act upon the next step almost immediately. Next slide, please. At this point, most of the teams, most of the engineers have an obvious question. If we can identify the root cause this quickly, why are humans still doing the same fixes over and over again? The answer historically has been about trust. We know how to fix these issues, but we do not trust systems to do it automatically, do it safely. Production grade automation doesn't start with autonomy. It starts with what teams already do today. Runbooks. Every SRE team has them, has plenty of them. Restart a service, roll back a config, scale a dependency, clear a stuck queue. But the very first step is simply turning those proven runbooks into automated workflows. And just as importantly, putting guardrails around them. Approvals where required, blast radius limits, automatic rollback if something behaves unexpectedly. This is not removing humans from the loop. It's about removing humans from repetitive, predictable work. Autonomy comes afterwards. Only after that, trust is earned. Good automation doesn't make systems reckless. It makes your teams that much more observant, that much more intelligent, that much more calmer when anything happens. Next slide, please. Now, whenever Gen AI comes up in operations, there is usually a lot of excitement and also a lot of skepticism. So let's keep this very real. In my opinion, Gen AI does not replace SREs. It doesn't make decisions in isolation. But what it does well is remove friction. Think about a real incident. You are on call. There is a flood of context, alerts, logs, traces, tickets, runbooks. Gen AI helps by summarizing what's happening in plain language, what has changed, what's impacted, and what usually works. It acts like a co-pilot, pulling the right context at the right moment. But here is the important part. None of this works without discipline. As you know, models drift, systems change. Yesterday's incident patterns do not always apply tomorrow, and this is why MLOps matters. Feedback loops, retraining, validation. Every incident should make the system a bit smarter, not just generate another report, another RCA document. In my opinion, Gen AI explains, AI ops executes, and SREs provide the guardrails. But when all of this comes together, observability, correlation, automation, and learning, the question becomes, what does production grade really mean? Next slide, please. At this point, it is important being very clear about what production grade actually means. If it only works in a controlled environment, it is still a POC, it is still a pilot. Production grade systems operate under pressure, they scale, cost, change, and human fatigue is all understood and brought down. They handle thousands of services, constant deployments, and incomplete information. They are designed with governance, cost control, and failure in mind. And most importantly, they behave consistently at 4 a.m., not just during a demonstration. Production grade isn't just a feature, it's a behavior. And to my last slide now. So if there is one idea I want everyone to live with, it's this. The future of reliability isn't about chasing better tools, isn't about doing a POC on the next best marketed tool. It's about building better operating models. When SRE provides the clear guardrails, when observability provides the real context, and when AIOps is used to reduce toil and accelerate outcomes. When all of this happens, you don't just get smarter alerts, you get smarter systems. Systems that are actually calmer, more predictable, and resilient by design. That's what production grade AIOps really means. When all of these come together and you are using the right tool for the right capability that it's built to provide. With that, I will end the discussion from my side and I will look forward to what questions or what other talking points you have. Thank you, Durai and Rudy.
Thank you, Amit. Thank you for walking us through the practical realities of implementing AI ops and autonomous operations. Thank you. And in the session, guys, we have navigated from leadership intent to technical foundations to real world execution. With this, actually, we move to the Q&A part. Okay, so we're open to questions.
Yeah, we already have a couple of questions here. There is a question for Pradeep. Pradeep, do I need to read the questions? You have, would you be addressing?
I got it. I think, thank you, Sandeep, for putting up that. And to be honest, we can always put ML models either in proactive or autonomous. There's no point. There's a bit of experience over there because since this proactive stage started, we all were really trying to do something with using ML model. And that helped a bit of predictions over there. And what I would suggest is you take those ML models, which you tried, the POCs, bring it to autonomous and make it more powerful with your LLMs or the intelligences over there. But there is no one is restricting, to be honest, you put in autonomous stage or in proactive stage. But all of us, see, we are trying with these ML things quite early. The LLMs things came pretty recent phenomena, but our right configuring the rules rules of failures and predicting something. We all started it pretty early. It's not a new phenomena. But what we were not doing, we were not taking decisions, or we are not taking the next steps out of that. And I think that is where we need to move to autonomous. Hope I'm answering that.
So there is also another question. Thank you for that, Pradeep. So there is another question. So do we have any POC or reference sample that can be shared which shows GenAI implementation on a project? So
Yeah,
I don't know how do we address
I
that.
can answer that, Rajendra. So, Sayed, I would encourage you to connect with me, but essentially there are plenty of examples where where Gen AI has been successfully implemented for operations, for SREs, for your DevOps teams. As I mentioned earlier, Copilot is always your number one implementation to go through your entire database of incidents alerts, give you the most relevant incident, the entire runbook for that. Secondly, by deploying ML models, by introducing context and correlation within your tools, you will get intelligent alerts. And this, with a combination of Gen AI, you will be able to pinpoint the exact issue where it happened. But I'm very happy to discuss this in more detail offline.
Sure. I think it's if time permits, then I can ask my question here. But if you prefer, then I'll ask my question offline. Whatever is okay with you.
You can
Yeah.
go ahead. I think you can go
All
ahead,
right,
guys.
perfect. So, thanks a lot. I have worked on a couple of projects, but most of them have been on the POC and open source level, where I have integrated a couple of tools in respect to Gen AI. However, when you come to production grade deployments and projects which are actually already live and running on customer environments, then integration of tools becomes tricky. First of all, how do you set the context for entire project for the tool? Now, if you use Copilot or if you use Codebase, like anything which GitHub projects provide, then the context is only to the code base that you have, and it misses the infrastructure context. However, if you give the context of infrastructure, then it misses the context of CI and SDLC. So
Mhm.
if you have I mean, this is too early to go into that kind of discussions, but my context is actually for smaller projects or whatever you're starting from POC level, you can integrate tools. However, the challenge which I have faced in my learning experience is when you are trying to integrate something which is actually already live, and then you want to integrate the Gen AI context-based tools there.
Yep, yep. Absolutely understand the question and appreciate you asking that. So one way that we have attacked this right now, if your observability or if the existing tool set that you are already using does not support dependency mapping or correlation, it becomes slightly difficult. But there are ways in which you could extract a subset of information or data points out of those tools and build some kind of a vector database or some kind of a database where your ML models can be run. So what we did, we extracted by using APIs of those tools 1 month, 1 year worth of telemetry information, data points, alerts, everything that we were able to extract onto a different database. We understood the patterns of what's going on. When was issue detected? What was the pattern leading to that incident or alert? And how can we use ML to get into a predictive state and start predicting some of that? With this, we were able to fine tune the model. We were able to now apply this model onto our own set of database where live alerts were also coming in until we were able to move to a completely different tool where infrastructure, application, database, all of these alerts were simultaneously coming in. Most of the organizations have one tool for infrastructure monitoring, a different tool for application monitoring, and different tools for network and security monitoring. I have seen a few tools where all of these get combined into one. And that's where some of the real insights begin to come out. But at the end of the day, Gen AI is an API call away where you can leverage the power of LLMs with your own data sets using RAG mechanisms to understand the contextual information that you already have and how can you start getting insights to it. So there are multiple ways in which this can be taken from a POC to a mid-size implementation and then get this whole thing implemented in production for at least medium-sized enterprises.
So if I understand you correctly, what you're saying is build the data set yourself, use a RAG or LLM, open source probably, and train it on the data set that you create from your collective experience of the platform, create the matrix, and then um, let it predict.
Correct. Correct. If your native tool does not already have that capability, if it does, half your battle is won. But as
Any
Pradeep
tool
also
that you
mentioned, and
recommend?
I would refrain to name any tools out here, but some of the modern tools like Datadog or Dynatrace have increased or they have increased capabilities around these areas. But the whole
Thank
objective to remember, Sayyad, is having a
you. Mhm.
good data foundation is extremely important,
Yeah,
right? Otherwise, you are pulling out data from diverse databases, diverse data sets, and it will become extremely difficult to get this into production.
thank you. One last one is the data set where you guys taking the data set out or creating it manually, or you used any kind of automation for that, or was it issue based?
No, so we were able to extract. So we first began with a month worth of data, and the models were not as accurate. So we went back to a year, and you can imagine the
Yeah,
volume of data points, the volume of data that we had to extract was just a lot. But
of
it
course.
gave us enough credibility, it gave us enough validation that the models are running fine for this one entire year worth of data points. And then we were able to extrapolate and tie back the feedback loop into your real-time tool sets.
Thanks a lot, Amit. Thank
Okay.
you.
Thank you, Amit. Thanks, Nadeem. There is one question before we come to the longer question. How much relevant is AI ops for database performance observability for SQL Server? Who want
Yeah,
to take this up?
I can
Yeah,
answer that.
yeah, sure, Amit.
So, in my experience, AI Ops is highly relevant for SQL Server, but not in the way most people initially expect. SQL Server already has excellent native metrics and diagnostics, so the issue is not about data availability, it's about interpretation at scale. Now, in modern environments, SQL Server rarely fails in isolation, right? Its performance issues are usually symptoms of something else, application behavior, connection pooling, query patterns, or upstream traffic spikes. Now, this is where AI ops adds real value. First, by correlating database signals with application and infrastructure telemetry. Instead of treating high CPU or blocking as a database problem, AIOps helps answer what changed upstream that actually caused the issue in my SQL Server. Second, by reducing alert noise, SQL Server can typically generate a lot of technically correct alerts, but AIOps helps surface the few that actually threaten user-facing SLOs. And finally, by pattern recognition over time, as I mentioned earlier, recurring query regressions or capacity saturation trends or incident patterns that humans miss, especially across many instances. And this is where AIOps excels. So what AIOps should not do is replace your DBAs or take a wild guess at your query tuning, but the real value is context, connecting SQL Server behavior to the broader ecosystem so teams stop firefighting symptoms and start fixing the issues that actually matter.
Yeah, and just to add on
Thank you for
top of
listening.
it, because the challenge what Amit building that context, I
Mhm.
think that's the next frontier, I would say. And how do we build this context? Is there something similar like semantic layer I need to build, create those contexts for these consumptions? I think that would be the next level of challenges, what I'm seeing coming in.
Mhm.
Pradeep,
Absolutely.
yeah. Pradeep, the next question, I think you wanted to take it up. Yeah.
Amit can also chime in. This is pretty much leadership related stuff, and I would like to understand. And this goes the same thing, and we all are insecure at this point of time with all these things happening around us. And thank you, Sylvie, for bringing in this question. I would like for us to understand again why we are in this situations and not to stay in a denial situations, rather accept, collaborate, co-create, because that's where we would really like to sell. The way I'm speaking, whether coaching is needed or the leadership, how to treat the people, but let's understand how do we really create skill sets which is required for our ops engineer at this point of time. I think that's the critical questions we are trying to address from an organization's perspective. As we move from stages to stages, also it requires our competency skills and more importantly, the mindset and culture changes over here, what we are trying to address over there. And it is my point of view, though I'm not a researcher at this point of things, but what I'm seeing, lot of things these ops engineers needs to start thinking that why I need to do, but machine doesn't have a questioning capability, the cognitive ability which we are telling. Related to that skills, what it is not to, it's not machine is taking away my job, as Amit is telling many places over there. It is how I'm up my game over there, correct? And creating those paths for this engineer is very crucial in the enterprise structure over here. And we are doing exactly the same thing. Are we creating more data engineers into the ops team? Are we creating more AI engineer into the ops teams? Are we creating more data scientists in our ops teams? Because this is the time where we need convergence and collaborations in a game perspective. So I would say that accept human and AI as the tool, and I usually talk that human in the loop, and most of us talk in that line. But I say this is a pair programmer kind of a concept where we are trying to leverage each other and produce best of results over there. And that's where I would say, as an ops engineer over here, the number one, I need to find out who is moving my cheese and what's the new role within that organizations. I need to find it out within the same organizations. That means if I'm trying to identify applications, but the applications landscape is changing more towards the AI data, then what are the new upskills? And then our NIT staff partners are there to train, keep it to ready and all those things, right? That can be done very nice way. Second thing is understand this why I'm changing and ready for that cultural change, accept, because this is more of a change management thing, Sylvie.
Yeah, I agree. And may I react? The reason I raise this question is because where I am and where I'm coming from, I'm really concerned about IT and HR departments dropping this skills set based on a framework that is meant to make the shareholders happier, right? So we're talking about productivity, reducing waste, speed, yeah. But the people that are working in the AI transformation actually know where the bugs and where the obstacles and where the loops are. And so we need to really create that environment where people are working together, collaborating together. And yeah, that I agree with you, has to come from the leadership, from culture. And when people work together and actually demonstrate that they're adding value because they're using their higher order thinking skills, then yeah, everybody wins. They are keeping their jobs, they're feeling secure, they're getting validation, they're getting recognition. There's a lot of things that we can be doing to actually spotlight the early adopters and show them as the heroes so they can role model and yeah, be inspirational for other
Absolutely.
people too.
Yeah.
Yeah.
Absolutely.
So and one
Absolutely,
more
Sylvie.
thing, because you mentioned context, make that your next thing to play with in the sandbox. Get the people to get really excited by feeling safe. So context and the big why. Yeah, because we have to. AI is here to stay.
Exactly, Sylvie.
So
And completely resonate with you on that. AI is here to stay. And this year, I have seen plenty of leaders have a FOMO with respect to AI. The mandate from the board is we have to adopt AI and we have to adopt AI next week. So most of the leaders have approached us, can we get this POC done? I have X amount of dollars available immediately, and I have to show some quick wins.
Yeah.
And what I have consistently seen that these quick wins, these POCs always fail, right? Because your data sets are disparate, you are pulling data from an Excel, you are not working with production grade information. But the real leaders in some large scale enterprises now understand that there is value in looking at the data foundation. There is value in upskilling my engineers on the actual meaning of AI, not just Gen AI and LLMs, but machine learning, right?
Yeah.
AI has been around since many, many years. Gen AI has just introduced a mandate in everyone that this every enterprise has to be AI ready. But my advice to all of the CXOs is this is not a magic bullet. You will not be able to transform your enterprise overnight. Let's make sure that your best engineers understand the value of AI. They are
Yeah.
upskilled. You have a few use cases, high impact use cases, but you will need a good data foundation to begin with. And then it's easy to unlock some of the AI use cases about that.
Yeah. And I think, Amit, if I may also just add one more thing, we need to also be looking ahead because the KPIs will change. The way that people are evaluated, their mid-year and their end-of-year evaluations. So the whole AI is going to transform everything. Sorry, I'm getting a call.
Absolutely.
It's going to
Absolutely.
transform everything. Yeah.
Yep. Absolutely.
So, in the interest of time, we'll move to the next question. So, there is a question from Rajita. Could you please help me to understand how to secure AI ops? For example, injection of false telemetry and that could trigger a shutdown. So, Amit, Pradeep.
Yeah, I mean, I can begin, and if Pradeep wants, and I
Go
would
ahead,
also be
please.
interested to hear his perspective. Now, there will always be instances of false negatives, false positives, right? And you should not be afraid of that, right? And as we discussed earlier, it is about fine-tuning your ML models. It is about repeated understanding and validation from the different alerts, different incidents, different data points that you constantly receive. But more importantly, have those guardrails in place. What I was discussing about earlier is yes, you can automate everything. Yes, you can build in 100% autonomy. Should you do it? Maybe not, right? You should only automate or bring in autonomy where this is repeatable, this is predictive. As soon as you see that this alert or something which is not repeatable is happening once every few days, you can automate to an extent, but some of these guardrails become extremely important. For example, should I automate shutting down or restarting my entire application? Maybe not, right? There are multiple milestones through which it has to pass if you want to automate your restart. So implementing governance and your guardrails is the answer to prevent an automatic shutdown to the instance that you are describing, Rajita.
Yeah, and it's thank you, Amit. And this is a great question, to be honest. And the real challenge is how do I understand this is a false positive and take actions? Because we are leaving a lot of things for machines to take on depending on these telemetry insights, right? And how do we design those guardrails? It is as good as I'm getting fake news and I'm going and acting, clicking on them, putting myself vulnerable. It is the same thing over here. And to be honest over there, again, the challenge over here, what are the guardrails? And my few cents over there, Amit, from my point of view is if we can start building, learning these false positives, the models who will learn these false positives and can understand these injections, create those rules that these kind of injections, and then if I find a hints of doubts, and because we designed something for fraud management in our systems, and where what we told that if the system identifies even a 5% doubt, it holds it. It allows a human to review it before releasing the orders, because that's where this thing is. In my perspective, if we have the guardrails designed to identify, learn, and take actions and put right point of interferences, that would be a great point.
Good. Yeah, before we wind up, Pradeep, there is one final last question for today, and I think it's a direct pointed question to you. So it's do I read that out, Pradeep, or?
Just a minute. What? Yeah. No, this is a great question. I think there's always a competition, tension, whatever you call, between developer velocity and reliability, and it is always real. Because what do you see? There is something happens in the production systems. The SRE team will come back and tell that, oh, okay, you do this, and I will leave it over there. No, you did it, and that is. I think that my first point over here is reliability, or the trust in the ecosystem is a shared responsibility, and that's why I always love this team where both your engineering team and reliability team work side by side, not as a separate organizations, and because that's where a lot of these things. So at Dell here, we actually made this shift left very real, because what we tell to our reliability team peers or members over there, keep giving us what do you think is causing most chance in the ecosystems, and how do I design it when I'm doing it? I think that feedback loop system is very essential into this ecosystem's perspective. And how do we really reduce this cognitive load is embedding reliability into early in the game, in the CI/CD pipelines, where developers are already using this. Why you need to do a chaos testing towards end, and why you are not inducing the chaos testing when you are pushing the code over here. See, there was a lot of those things, but I would like to wrap up. One thing for sure, it has to be a shared responsibility. Kirubakaran, if your question I'm answering.
Thank you for that, Pradeep. Now, before we actually end this session, there is a quick poll on the screen. I request all the participants if you could respond to this. We'll just give you maybe a 30 seconds or a minute here. We have just 2 questions before we end.
It's a question.
If you could just write your responses, that will be really helpful. Yeah, maybe another 15 seconds. Maybe the last 5. Great. We move to the next question. The next. Yeah. This is the easier one.
It's a feedback loop. I liked it.
Meanwhile, just think.
So while people are responding to the poll, I would like to take this opportunity to thank Pradeep and Amit for the wonderful session, for taking out your time and sharing your experiences with all of us. I'm sure the participants as well as all the attendees here have benefited immensely from this session. Thank you so much once again.
Right.
And a very and as extending the thanks to our own Durai, who is here for taking out time and being here and throughout the session. Durai, thank you so much. And thanks to all the participants for attending this session, being there from the first minute till now, being a calm listener and also asking those questions, which I'm sure were really valuable for others as well who were attending the sessions. Thank you so much. We'll come up with more such webinars in the future. Till then, thank you so much and have a wonderful day ahead. Thank you so much, everyone.
Thank you, everyone.
Thank you.
With that, we'll end
Thank you.
this session here. Thank you. Thanks,
Thank you.
Amit. Thanks, Pradeep. Thank you. Bye. Bye.
Thank you, Raj.